Alrighty. So this is lesson number 17. Symbol for true population proportion is which of the following? P with a little squiggly, P with a little diamond, or a little upper arrow, or P?
P.
Yeah, see.
Hey. And for the next two questions, suppose n equals 100, p equals 0.25, and I don't know what you call that, but p with a little arrow above it equals 0.10. The requirements for constructing a confidence interval are satisfied. True?
Wait, doesn't have to be. Oh, no, you're right. That is.
All right. The requirements for conducting a hypothesis test are satisfied.
I don't know.
Let me see. Hypothesis test. I think it's funny how I have to go like back in lessons just to get some of these questions.
So for the hypothesis test, it's true because it's less than or equal to, and the answer is 10. So
Okay.
greater than or equal to, right?
Yeah.
Greater than or
All
equal
right.
to. So it's
Yeah.
true.
Yeah.
Hypothesis.
That's true.
So
A
is it
study. Oh, go
number
ahead.
2? Did somebody work number 2? Yeah, it's true. Number.
All right. Use the following information for the next 5 questions. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find, P with a little arrow above it, the point estimate of the proportion of the first-degree murder defendants who are found guilty in this state.
0.017.
Would be 45 divided by 60.
Yeah.
Yeah.
So that P. Yeah. Or 0.75.
Yep. Sorry if I'm like kind of slow and tired and bleh.
For
All
some
right.
reason, I think I just calculated wrong.
For what?
The last one. But I got 0.75. That's what you guys said, right?
Yeah.
Did you do the test already?
The test.
Oh.
I mean the quiz?
Me? No.
No, Lisa.
No.
Oh.
All right. Determine margin of error for this 95% confidence interval. Round to the nearest 3 decimals. All right.
Well, we can just put it up on a little thing.
All right. So.
Can't you just use the Excel thing to work it?
What was that?
Can't you
Use
use
what?
Excel Z test for proportion to get the confidence interval?
But we're looking for the margin of error, right?
Oh, never mind.
Yeah, margin of error for the 95% confidence interval. So I love this big equation.
Wait, our P is our 45, right?
I thought it was 0.75. I don't know.
That's right. No, that's right. I was just getting
Yeah.
which P wrong, yeah.
And then we do
Go ahead.
1.96. So that's our z-score. Square root 175. And n is 100, right? Or no? N is 60, right?
60.
Yeah.
Job, Braxton.
So is it 0.75 plus or minus the 1.96? Is that how you set it up?
No, it's
Yeah,
just
so
oh. Maybe I'm
no,
off.
go ahead, Heather. Go ahead, Heather.
I thought it was the Z with the square root of P parentheses 1 minus P all over N. Isn't that the one we're looking for? For the margin of error?
Yeah.
So it's
So it's 1.960 times the square root of 0.75 with the parentheses of 1 minus 0.75 all over 60. Right?
Mm-hmm. Rounding to the nearest third decimal place. Okay.
Braxton, you can go eat that on the wood if you want to go watch the movie. All right, I got 0.10957.
5, 7.
I don't know what the heck I can do. Oh,
Uh-oh, the train's coming. Can you guys hear that?
Yeah,
That's kind of funny.
so 0.11 is our answer. Is that what you guys got with the rounded up?
I feel like I'm doing it wrong. Are you putting in the probability applet? Or no? Am I doing something wrong?
No,
Okay.
I'm probably doing something wrong.
the margin of error. Isn't it like the P with the little thing on the top plus or minus C score divided by the square root of the P
Yeah.
parentheses? Okay.
And what I got was -1.260. Or no, 266. That's what I got.
That's not even close to what I got.
Oh, come on.
This is the formula I use.
Oh, you froze.
Hold on a minute. All right. See? Isn't that the formula that we use?
That's not what I put down.
That's not what I would put down either.
This is what I use.
Because in the homework it says formula for the margin of error is that. Not
but
in the
you're
homework,
also-
I'm sorry, in the...
The point estimator too, right? So the point estimator is 0.75.
Wait, she's right, I think. So, but
Yeah.
we're using regular P.
Yeah, we need our regular p-value.
Yeah, so we're doing, is it 45? Is that what it is? Yeah. So,
I don't know.
45, 1 minus 45 over 60, 45 times divided by 60, negative 330 square root. What'd you get, Heather?
My last one was 0.11, but I did the 0.75, and that was the point estimator, but we needing to use the true population.
Not really.
Okay, so
Yeah,
you have
right.
to, okay, so you have to do 0.75 plus or minus 1.96 times 0.45. I'll just write it out. Because it says estimator. Oh, wait. Sorry, I was looking at the wrong one. Let's find it. Not again.
We'll do that equation next.
Formula for margin of error. C is 1.96.
Okay, so when I do 1.96 and then the point, oh, never mind, because I'm moving anything right. I got 0.12588.
Okay, that's what I got when I changed my p to 0.45.
That's what I'm getting. Four, 5.
But I really think you have to use, to do the margin of error, you have to put in the point estimator in there too, don't you?
That's not what the equation says in the notes, though, in the book.
Yeah.
So that's what leads me to be.
Oh, that's for the confidence interval. Sorry.
Yeah.
Yeah.
Well, it's saying determine the margin of error for the 95% confidence interval. So, and then it says input the lower bound is the next question. So it might lead me to believe that the other one is right because it's confidence interval.
That's what I think too.
So are we going to go with the equation you used, or are we going to go with the larger one?
I think the answer is 1.26.
That's what I had.
That's
from
what I
the
got.
beginning.
Like that, that's fine.
Did you have negative or did you have positive?
Positive.
Positive.
Okay. Are you doing 1.266 or are you guys doing 1.26?
1.26. Oh, it's 0.26.
Sorry, 0.126, yeah.
Okay, we'll go with
Darn decimal.
we'll go with that for now. And then input the lower bound. Hey guys, 1 second. My doctor's calling me. Oh, it's Taylor.
All right, I'm going to start this next one.
I got 0.640.
Okay.
Oh, yeah, because you already did
His phone number is 208-319-4322. And then his date of birth is May 6th, 58. He is self-employed. He has his own CPA firm. And then I was wondering if it's possible to get like I don't know, I guess a pre-diagnosis of what the doctor was, or what we're looking for on the MRI. I just wanted to research it for myself a little bit. Yeah, we're saving the MRI for tomorrow morning, 9 Teton.
So Lisa, it's 0.75 plus or minus 1.960 times the square root of 0.75 parentheses 1 minus 0.75 all over 60, right?
Yeah.
Okay. All right, so my lower bound, I got 0.640.
And that's what I got because I just used the little Excel sheet.
Oh, I should do that. Okay. For my upper, I got 0.895, so 0.86.
Sorry about that, guys. All right, so what did you guys get for the lower bound? Number 8.
40.
0.640.
Yeah.
And then for the upper bound,
868. I think.
0.68.
Yeah. 0.680.
0.680.
Yeah.
Okay.
But it sells in the Excel sheet.
Wait, I got 0.8759.
For the upper bound?
For my upper bound, yeah.
Did you put the X is 45?
No, I have it as 75. I mean, yeah.
Why do you have X as
Did we need to change it?
Yeah, you have to change those numbers. Because we have 40
Oh, yes.
defendants or whatever and 60 people. So
Yeah.
X is 35 and N is 60.
Yeah. So it is 0.680 for number 9.
But
Yeah. Okay, cool.
Okay.
All right. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? Decrease, increase, or stay the same?
I wrote that down.
Isn't it decrease?
Yeah. Increase sample size, decrease more the
Yeah. All right. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose p equals 1/2. What is the smallest n can be, and both requirements still be met? Okay, Lisa, this is where you come in, shining star.
So I could not figure this one out.
Neither could I.
I thought I did, and I still couldn't.
This one's like above me, like it's God level.
Sometimes I get my husband to make sure. So there's 1 minus 1/2, so that's 0.5. 0.5 equals 10.
So you just do the n times p is greater than or equal to 10, right?
Yeah.
Wait, sorry, say that one more time. It kind of cut out.
So you do the n times p is greater than or equal to 10.
It's greater or equal to 10.
And then how I thought you got it was just by trial and error.
Michael, come here. I'm just making sure I'm doing it right.
No. Call them big shots.
But do you have to make sure they are okay with both of them?
Yes, you have to do both.
Okay. So then the other equation is n times 1 minus e is greater than or equal to 10.
Run that 1/2 thing again.
Yep.
So
10 over 2 equals 10 and n equals 20.
this is
Minus 1/2 and over 2 equals 20.
so they're both the same. They're both 20.
So,
So 20.
Is it 20?
They both equal 20.
Okay.
But in my other equation, it doesn't. 1 minus 0.5 times 20. Oh, never mind. I put it in wrong.
I
Just
was gonna
kidding.
say, what you talking about, Willis? All right.
What was the quiz answer then? For the 4/5?
So I know I'd have to look at the quiz, but I got it right.
I got it wrong.
I did too.
Okay.
So, huh.
What was the answer? I think I don't remember. So 1/10 is 100. Because that was on homework.
Yeah.
We've done that homework one before, yeah.
Yeah. All right. For the following information, use it for the next 6 questions. For the water quality study and the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using a significance level of 0.05 with the following hypothesis. P equals 0.6, P is less than 0.6. They collect new data, and this time n equals 80 and x equals 38 to indicate good health. The conditions for conducting the hypothesis test are satisfied. So true?
Sorry, feeding.
Random test. Then you have to do that thing again.
Are you going to say true? Or false?
Wait, why did you say true?
I say true. Because so n equals 80. Sorry, guys.
It's true.
Yeah, it's true.
But But for the requirements, you have to do a simple random sample, right? No, just kidding.
No.
You just have to do the, I don't know. Let's go.
All right. Number 14. What is P? Round to the 3 decimals. How do we find a P again?
The x minus over or divided by n.
That's 0.75.
Yeah.
Yeah. Find the test statistic. Round to the nearest 3 decimal places.
The formula for that one again?
Test statistic.
It's the z equals 1.
That was in the last lesson, right?
Was in this lesson.
Really?
It was in this one?
It wasn't last lesson, yeah, we just learned, yeah. It's the P with the little house on top minus the regular P.
The
Divided-
huge one. The huge, huge one.
I just want to cut off my leg right now.
Giving you any muscle relaxers or just pain medication?
Yeah, but I'm not allowed to take them till tonight because the first time I'm supposed to take them at night. So they just prescribed them today. Well, I just started getting spasm like last night, so
Good.
yeah. It was really scary. I woke up at like 2:30 and my like legs wouldn't stop like making me jump. Every movement was just killing me.
Yikes.
So I called my brother, like, come give me a priest blessing at like 2 in the morning. All right.
I keep pushing in the wrong direction.
I feel like there's so many more equations in this.
I know.
Okay, I got 2.282. Then you got to do the math.
0.282.
Yeah. That's what the z-score is.
0.282.
Yeah.
Sorry, I have to write it out.
Yeah, I do too. Easier for me.
This one. That's,
This is why people have software called SPS.
can't you put this in the?
In Excel or in SPS.
Yeah, you can. No, I don't think you can.
Okay.
I'm getting a different answer, but I know I'm doing it wrong, so.
I got negative 2.28. I think that's wrong.
2 point, well, okay, it's supposed to be like the 0.475 minus 0.6.
Yeah, that's what I did.
Oh, I got negative 2. I'm sorry.
Negative 0.282.
2, yeah. Negative 2.282.
Yeah. Yay.
Now that makes more sense in the app.
Okay.
Area is 0.011.
The p-value?
Yeah.
0.0011? About 0.001? Wait, sorry. Say that one more time.
0.011.
Cool. All right. What is the decision for this test? Reject the null hypothesis or fail to reject the null hypothesis?
Okay.
Reject.
Reject. All right. Which of the following best summarizes the conclusion of this test? There is insufficient evidence to conclude that the water quality in the area was not decreased. There is sufficient evidence to conclude the water area has not decreased. There is insufficient evidence to conclude the quality has decreased. There is sufficient evidence to conclude that the water quality in the area has decreased.
Has decreased?
So
I think so.
has decreased.
I'm always bad at these.
But so it has decreased. So since we rejected it, isn't it insufficient?
No, if you reject it, sufficient.
It's sufficient, yeah. Okay, that's right. Sorry.
Would be and dog.
All right, you guys want me to submit it?
Yeah, go for it.
I'll submit it. Take one for the team. Submit. All right. Let's see. All right, we got number 7 wrong. And number 9. But I put 0.68 as number 9. Is that right?
No, it's 0.64. 0.640 or something like that.
0.64 what? 640? Is that? But that's is that the lower bound? Because that's what I put for the lower bound is 0.64. The upper bound I put 0.68.
Yeah. Those are wrong?
Number 9 is wrong. The lower bound is correct. The upper bound is not.
Well, that makes sense.
But I think I just put it in wrong.
I put
I don't. Are you sure we're supposed to change the numbers for the value when it's for the upper bound?
it's 0.860 for, is that not what you're saying?
I put 0.68.
It's 86.
860.
Yeah.
Did you submit yours?
No, but that's what I pulled my thing back up and it's 0.860.
Okay.
Lower bound is 40.
Okay.
I told you wrong.
7 was
Yeah.
wrong. So.
7 was wrong also. Those are the only 2 that are wrong. That's what I was getting when I was doing that.
Which numbers did we use for number 7?
Number 7, we used.
Was that the 0.75 one?
Yeah, it says create a 95% confidence interval for the true proportion of the first-degree murder trials in the state. So we used 60. So the random sample is 60, and of these defendants, 45 were found guilty. So Project.
So we need to find out what our P is.
For number 7,
Yeah, our regular P is just 0.75, right? No, that's not right.
That's our point estimator.
yeah.
That's our estimator. Okay.
Because I think we did 0.75 instead of 0.45.
Yeah. So 0.45 is our P value then? Or our P?
Yeah, I think so. I don't know.
Oh, this medicine's making me sick.
Did you eat?
Yeah, I did, but still, like,
Okay. Then we probably need to do the 0.75 because what did we put in for our answer?
1.26.
Okay, so instead of the 45, we have to put the 0.75.
That still just doesn't sound right though.
I want you to try it and then I'll.
let's try it. Yeah, because you still get more chances.
All right, so 0.11 then?
But it says 3 decimal places though. That's the thing.
But if you round up, I have 0.1095, so the 5 rounds the 9 up. You want me to submit and see?
Yeah, go for it.
Okay.
It says, oh well.
We got 7 right,
Did we get
What,
8
what?
right? And 9?
and we got 8 and 9 right as well.
Okay.
Wait, so what's the answer?
So the answer for number 7 is 0.11. And you already changed your answer for 9, right?
Yeah, 0.68.
8.6.
No.
0.86. 0.86.
Maybe we shouldn't discuss our group.
All right.
Okay.
Cool beans.
That was the last one.
That was good.
Okay, so we have to discuss our group project.
Group project.
Okay, so
So
what is our question?
Well,
I feel like the M&Ms or something like that.
what
what was
it?
that?
Trying to see what Jake.
Why don't you use as our group question?
The frequency of find the frequency of what color M&Ms was the most common from a bag of milk chocolate M&Ms. Y'all want to go with that?
Yeah.
Sounds good.
So what is the experimental unit?
M&M's.
This is fine. I'll do stuff by myself. What is your response variable?
Response variable. We're gonna be drawing out the M&Ms. I think. Let me Google it.
Would it be what color we want it to be? That'd be.
It's just what your dependent variable is.
Yeah.
So
Would it be the type of brand?
No, it's all M&Ms, like the brand M&M.
So your dependent variable is the M&Ms.
But this is
Independent.
response variable. Is that the same thing?
Yeah, it's exactly the same thing.
So it's M&Ms.
Yes.
Is your response variable quantitative, or categorical?
Um,
Oh, quantitative.
yeah, definitely quantitative.
And then, which statistical method are you going to use for your study? Quantitative, one sample, sigma known. Quantitative, one sample, sigma unknown. Quantitative, huh?
Is it 1 sigma unknown?
Is that it? There's more options.
Okay, read them off.
Quantitative, 2 samples paired dependent. Quantitative, 2 samples independent. Probably quantitative, 3 or more samples. Because when we have to do more than one sample to find the frequency of the colors in a bag.
I want to say, yeah, because we'll each do our own bags, right? So that'd be 4 different samples added to it with their numbers of each color.
And
Yeah.
then do an ANOVA test.
Mm-hmm.
Yeah, an ANOVA test.
Right, now it says, what are your null and alternative hypotheses?
Well,
Green
we can
Green
come
will
up with
be-
whatever we want.
will be the most frequent one.
Green will be the most frequent one. Let's go with that.
I think it's brown. The ugly
But
Well,
it's
Lisa,
Christmas,
it's
so don't buy the Christmas one.
We should just buy the Christmas one. Okay, so green. So how do we state that? H-O.
Oh, HO does not equal, wait, what does ANOVA's? Will equal green.
And then the other one will not equal green?
No, it'll be, one will be not the same.
No, I mean like the HA will be the not equal green, right?
Yeah.
Okay. Question number 8. Which sampling method will your group use? Systematic sampling, cluster sampling? Oh. Yeah, which sampling method? I need to go look that up.
simple random sample. Because we're just drawing one at a time, right?
Well, no, because we're looking at all the numbers in the bag, so we're looking at all of them.
But we're just drawing random bags. We're not.
Oh, okay. Yeah. I know what you're saying.
Does that make sense or not?
Yeah.
So which one is
Our systemic random sample is to the K choose random one. So we'll choose random one and then we'll choose the next like 6 random one. That's the systemic.
So when we're picking them, we pick one up and then we go count back 6 more and pick another one up?
That's if we use the systemic random sample, yeah.
Which doesn't seem the best. Is that the one that you guys want to go with?
Let's just do the simple random sample and just grab a bag out of the store.
That's what I thought.
I think so too.
That's what. I mean, Jake seems to know what he's doing. We can ask Jake, but yeah, he's not here. I saw him today on campus, but
So was it both of his in-laws that passed away at the same time?
I think so.
Oh, that's so sad.
Yeah, they got like a car accident or something. Yeah.
So it says, if you choose random sample, please describe in detail how you will pick, ensure the experimental units are selected randomly. Okay, but That's just this doesn't make sense.
Just read that one more time.
Okay, so if you do choose random sample, please describe in detail how you will ensure that experimental units are selected randomly. The wording developed.
I will go to the store. I will randomly select a bag of M&Ms.
Well, we need to make sure we pick the same size of M&Ms. Like, we all need to pick the same jumbo bag or the
Oh,
Yeah.
cover.
Look for your jumbo bag. Let's just do one plain bag of M&Ms.
Like
Small-
the little ones, or do we want to do the big ones? Because I like more M&Ms.
a normal package.
What about the king size? Because I want to eat more.
I don't want to eat those. I'm fat enough. I don't want to eat them. From what I'm getting confused with this one because is it just about the bag or is it about the M&Ms in the bag?
About the M&Ms in the bag.
I
So
think so. Where are you getting this information from, by the way?
it's the final project packet that you turn off.
Come on, Heather. Just kidding. I haven't even looked at it either.
So I don't know. I hate stuff like this because
What other questions are there?
there's like 17. The next one is describe in specific detail how your group will collect data using the sampling method stated in question 8. So that's why I'm like it can't be an SRS because we're just opening the bag and looking at M&Ms to determine which color frequency is more.
Well, this is how I think it's going to work. We grab the bag of M&Ms. We dump out the bag of M&Ms. We just separate the red, the green, the blue, brown, whatever other color there is. And then we just figure out which one has the most. And
But
then,
that's a cluster or something, isn't it?
yeah, make it a cluster.
My definition of a cluster sample is group them together, then sample the group, taking all items in one or more blocks.
That's what we're doing because we're taking all those items and finding a number.
Yeah, so just do cluster.
What sample sizes are you planning to obtain per population? Holy crap.
What sample size? We don't know yet.
Okay, so describe in specific detail how your group will collect data using the sampling method stated in question 8. So that's just clustering them all together and pulling the numbers.
Right.
I should not be in charge of writing this all down. Yeah, this is where we have to know what sample size we're planning to obtain per population.
I think that's just have to wait.
We'd have to get our bags of M&Ms to determine that, right?
Yeah.
Yeah.
One bag of M&Ms, maybe.
Yeah, just for now.
And
When does this due? End of
we
semester?
turn this in by the 13th.
Of this month?
This, our 14th,
Oh, gotcha.
that has to be due.
Okay, and are you doing that? Or we all separate?
Well, we all sign it. And we all,
Oh,
I'll get to the rest in a minute.
okay.
This section should have enough detail that a responsible, intelligent person that has never taken a statistics course could replicate your study. Guys, I should not be writing this then. Please review the requirements in the text for your choosing method from step 6 and discuss why your study is in alignment with the requirements. Okay. 6 was quantitative 3 or more sample.
Yeah.
Because we're using multiple bags of M&Ms to determine our frequency.
Yeah. Hey guys, one more second. My other doctor's calling me.
Yeah. Nope.
This is Taylor.
Survey.
Which question are we looking at? I just got it pulled up.
Okay. Look at 9 and 10.
Group select data using sample data. Also, what sample size are you planning to obtain per population? I don't know how many is in a bag.
I know, I think that'll have to wait until we each get a bag and determine, hey, we're only going to use, I have 30 M&Ms in my bag, you have 31, so maybe we just discard one randomly, right?
Yeah. Yeah, that's what I was kind of thinking. We'd choose a set number for everyone to decide on.
Okay, and then the number 10.
Please review the requirements in the text for your chosen method from step 6. What do we do for there?
That's the quantitative ANOVA one.
Nova. Okay.
So we're each going to have a bag of M&Ms.
Yeah.
And then 11 and 12 are no. And then we could skip. It says skip to 19 if we say no. Okay. So, what did you say, Heather?
I was just reading it. Sorry.
So now we have to decide like whose roles are whose. So I'll try to type this up, which is going to be really, really bad, and just email it out to everybody. And then, like, I'll email it to you, you email it to Taylor, Taylor email it to Jacob, and then I guess Jacob will submit it maybe. But I don't, if he's not around, I don't want to rely on him to submit it.
I know he's dealing with tragedy right now, so.
So maybe we just try to do it and then he has to
Yeah,
sign it.
let's just sign him. I would text him. I'm using my phone for this. Let's just have everyone choose assignments over text, and then he can be a part of it or not.
Okay.
And we each have to choose 2, right? Well, some 2, some 1.
So I guess I would be like the main writer for designing the study.
Yeah.
But she said like if she revises it or whatever, we won't be counted late. So that's good.
Yeah. Right. What are our other jobs? Main writer.
Step number 3 is main writer for describe the data. That must be in a separate.
Oh, here we go. Summarize estimates to collect the data document. Because we're all part of that part.
Mm-hmm.
All right, how good are you with PowerPoint?
I'm okay. It's not going to be real fancy.
I am not very good with it. It's been a long time since I've dealt with it.
Yeah, I haven't done it in a long time either.
I'll do describe the data.
We'll just let the, yeah, I guess I could do the main writer of the study and do the PowerPoint.
Well, that's a lot. PowerPoint's going to be a lot.
Not if we all work together to do it. I think we could all work together. Say, hey, you get these 2 slides, you get, well, I don't know how it's all going to be laid out though.
Well, and with me doing the data, I can create it and I can like send you like the links to the different graphs and stuff.
Yeah, well, if everybody does their part, then we should all be able to pull it together.
Yeah. Do we really have to sign it, or just type in our name?
Well, that's kind of what I don't understand because it could have been electronic signature. So does that just mean typing it in?
Yeah. That's what we should do.
So maybe I need to get it, oh, this is due the 13th, so today's the 10th. Well, we actually have to have it done by Saturday night because at midnight or whatever on Sunday they're
Oh, I'm doing
yeah.
it down, whatever.
I just know I'm not going to write it right. That's my thing.
Well, that's why she has to approve it or not to let us know.
Okay. I'll try it. And I'll try to get this done tomorrow and send it out to everybody's email.
Thanks for being on top of it.
Not really. I just knew we had to get it done. Okay, so when we state your research question, we are trying to determine, so I would say we are trying to determine the frequency
What?
of what color M&Ms was the most common from a bag of milk chocolate M&Ms.
Yeah.
Okay. What population are you studying? M&Ms?
M&M.
Frequency of color?
Oh, yeah. That'd be a good one.
All right, experimental unit is M&Ms. I don't get the response variable. So our variable of interest in our experiment is just the,
Back to the beginning.
huh?
Let me go back to the beginning of my notes.
Oh, we would hope that's something.
Maybe I didn't write that good of notes. Well, we found out today it's definitely a boy.
Oh, I was going to ask you if you're still doing okay. How far along are you?
19 weeks now.
So last time you had your miscarriage at 14?
I think so. Yeah.
So you're good. You're a good ways away.
Yeah.
I don't understand number 4 very well. Is it just M&Ms?
Response variable. I don't know if like with their morning was that? Google it.
Well, it's a dependent variable.
Right.
Okay. A variable in a functional relation whose value is determined by the values assumed by other variables in the relation.
That one did nothing. A response variable is a particular quantity that asks the question about your study.
Yeah.
And
It's the variable being tested.
Sorry, guys.
It's okay.
so would it be our green M&M then?
I don't know. Taylor, is green M&Ms the response variable?
Yes.
You're not just saying that because you're high, right?
I'm yeah. I'm not saying that just because I'm high.
Okay. So Taylor,
Mm-hmm.
out of these jobs, what do you want? Main writer for make inference or main writer for take action?
Main writer for take action.
Okay, and so I guess we'll write take for make inference.
Mm-hmm.
I'm not gonna lie, I'm a little worried about that. I know he has a lot going on, so.
I think he'll be fine. I talked to him briefly today, so yeah. If not, I can go to his house and knock on his door.
Did he fly out to South Carolina?
No, he actually had to stay back. His kids went and his wife went. So yeah. Are we done with the questions
I guess.
or not?
Yeah.
Okay.
I'll try to get
All
it all written up and then get it out to you guys tomorrow so that way you can put your names on it.
Okay.
I'm a little bit critical about our hypothesis for the ANOVA.
You're what?
For the ANOVA, because the hypothesis is always all means are equal, and then the